EDX Core Pure, Complex Numbers 1, Introduction. Linking complex roots to quadratic equations. So in this little investigation we're going to consider the roots of quadratic equations. So here I'm going to start off with z squared minus 2z minus 8 equals 0. So if we factorise this quadratic equation, we get z plus 2 times z minus 4 is 0. So the roots of the equation are z equals minus 2, z equals 4. Now the interesting thing here is if we look at these two roots, if we look at the mean of these roots, so the mean of these two roots would be minus 2 plus 4 over 2, which is 1. And the interesting thing is if we look at the vertex, we notice that the x-coordinate is 1. So the question is, does the mean of the two roots of a quadratic give you the same value as the x-coordinate of the vertex? So the mean was 1, the x-coordinate of the vertex was 1. Does the mean always give the x-coordinate of the vertex? And that's what we're going to investigate. So if we look at this new problem, can we solve the quadratic equation z squared minus 2z plus 5 equals 0? I'm going to solve this one by completing the square. So half of minus 2 is minus 1. So I create the squared. Minus 1 squared is of course 1. So I need to take off 1 before I add on the 5. So we get z minus 1 squared equals minus 4. Taking square roots of both sides carefully, z minus 1 is plus or minus the square root of minus 4, which we now know is plus or minus 2i, and therefore z equals 1 plus or minus 2i. So we've got two roots here. We've got 1 plus 2i and 1 minus 2i. And notice that they are a conjugate pair and will always be a conjugate pair for a quadratic. So it doesn't matter which one I call z and which one is z star. So I've decided that z is going to be the 1 plus 2i, and therefore its conjugate pair I can call z star is 1 minus 2i. But the interesting thing is if we look at the mean of z and z star, we get 1 plus 2i plus 1 minus 2i all over 2, which gives me 1. So we've solved the quadratic. We've noticed that we will get a conjugate pair, and they would always occur in a conjugate pair. We called the 1 plus 2i answer z, and therefore the 1 minus 2i answer is the conjugate z star. And if we now look at the quadratic in a bit more detail, if we look at the graph on the right, we can see clearly that it has a vertex at A, which is the point 1, 4. And if we look at the roots z and z star, and if we consider the mean of z and z star, we get 1. So the curve has a vertex at the point 1, 4. So we can conclude that the mean of the roots will always give the x-coordinate of the vertex, regardless of whether the roots are real, repeated, or, in this case, complex. So that's the end of complex numbers 1, an introduction.